Hello guys and welcome to your very next video on data structures and algorithm using Python. So today we will discuss about linked list. What is a linked list? Why do we need linked list? And why do we prefer linked list over array? And when not to prefer linked list? These all questions will be answered today. So let's see. Okay. Linked list is made up of nodes and a node is made up of data and pointer. Wait, open with paint. Yeah, okay. So linked list is made up of nodes. This is a node, this is a node, all these blocks are nodes. Okay, and these nodes contains data part. This is data part, this one is data, this 2 is data, this 3 is data, this 4 is data, and the next part is pointer. In this way the linked list is created, and this little cross, can you see that? That is null. That indicates the end of the linked list, that I cannot go forward. So let's see some advantages of linked list. Dynamic in okay, linked list is dynamic in nature. What do I mean by dynamic? Dynamic means insertion and deletion in the linked list does not need a rearrangement. And what do I mean by that? I mean to say, for example, suppose you say to your mom that, Mom, I need chocolates. I need 5 chocolates. You exactly specify how many chocolates you need. That is same as array. You declare the size initially, that my array will contain only 5 elements, nothing more than that. Then your mom bring 5 chocolates to you. Okay, but then in the case of linked list, you never declare the size. You say to your mom, I just need chocolates. That doesn't matter how many are they. They can be 100, they can be 200, they can be 6, they can be only 2. That depends on you. You can increase the chocolates. You can ask again and again, Mom, I need another chocolate, another chocolate. That's how nodes are created. You create 5 nodes, then you need a 6th node. You will say I need 6 node, but you cannot do it this in array. Okay, that is the biggest advantage of linked list and biggest disadvantage of array. Insertion at first node is easy, O raised to 1 complexity. Okay, so the first node in linked list, this first node in linked list is called as head. Let me write on it, brushes. Yeah, this is head, and this is null pointer. Okay, so initial first node is easy because we know the head. To access any element in linked list, we first go to head, because we only know the head, and then we go to the next node by using this link, and then we go to the another node by using this link, then we go to this node by using this link. This is how we traverse a linked list. Basically, we know the head, so we can insert there. We can make a node like this. I made a 0th node and I will call it as my new head, and I will just connect it to 1, and I will erase this head. So my new head is now 0, that is connected to 1. So this is my totally a new created linked list. How much time it takes? O raised to 1. Removing the first node takes a O raised to 1. That is nothing but removing the first node takes O raised to 1. Suppose I want to remove this 0th node. Okay, I want to remove this 0th node. So I will just remove it like this, and I will make the first node as my new head by deleted that link in the 0th and 1 node, and also deleted node. Can store items of different sizes. That means that suppose there is an array can only of integers, and array can only of characters. It cannot contain both integers and characters. But in the case of linked list, a node can contain an integer and it also contain a character at the same time. So now let's come to disadvantages. Indexing. So what do I mean by indexing? Indexing is nothing but traversing of a linked list. Suppose there's a question that says print the fifth element of the linked list. That is fifth element, right? That means we need to print 5. So how will I traverse the linked list? First I will access the head, because I only know the head. Then I will traverse by these links, these pointer, to second node, then to third node, then to fourth node, and finally I will go to fifth node and I will print it. Correct? This is the way of indexing. How much time it take? It take O raised to 5, almost 5 jumps to go to 1, 2, 3, 4 jumps. Basically 4 jumps means to print the element we need n minus 1 jumps, almost O raised to n jumps. So the complexity is O raised to n. Indexing complexity is O raised to n in the case of linked list. But what in the case of array? In the case of array, here is the array, wait. But in the case of array, suppose we need to index the third element. We need to see this element, second element. So we will directly say print a2, and how much time it took? It takes O raised to 1 seconds. O raised to 1. Okay, so here it is. Array takes O raised to 1 while linked list take O raised to n. Now let's see the next disadvantage, that is remove from the end of a linked list. Okay, now removing anything from the linked list is same as the inserting. Suppose I want to remove the last element, so I will go to the head and then I will use the links to go to the last element and I will just delete it. And when I will delete it, I will make the previous element as my last element by making its link as null. In this way the element is deleted in linked list. How many steps it took? It almost took O raised to n jumps. We jumped from second node to third node, third to fourth, fourth to fifth, fifth to sixth. Correct? So deleting takes O raised to n jumps, O raised to n complexity. Now take more space due to pointers. Okay, that's one of the major point. Actually, in the case of array, I suppose I'm making an array of 5 elements, so I will store 1, 2, 3, 4, 5. But in the case of linked list, we will store 1, pointer to the next element, 2, pointer to the next element, then 3, pointer to the next element, and 4, and pointer to the next element. So in this way, the space is wasted. A space for pointer is also needed. Don't allow random access. I already explained you. Suppose we want to access the third element in array, we'll just type print a raised to 2. But in the case of linked list, we need to traverse sequentially to that node. Suppose there is a question in which we want to reverse our name. Suppose the name is John and we want to print NHOJ as our output. Correct? We can store John in two ways. We can store John in array A, or a linked list like this, and this is null and this is head. In the case of array, we can directly reverse it by printing. We will first write print A3, then print A2, then print A1, and then print A0. This is how will be done in the case of array. But how to do in the case of linked list? In the case of linked list, there is no way to come back again. We can only go forward. So that's the reason where doubly linked list comes into play. Doubly linked list is nothing but which contains two pointers. Okay, here is a doubly linked list. Here you can see it. In doubly linked list there are two pointers. One pointer that is going to the next node and one pointer that is making you come to the previous node. So we also have the head, this is head, and we also have the tail. This is the last node is called as the tail in the case of doubly linked list. We have head and we have tail. By using tail we can go to the previous node, then to the previous node. Okay. Now let's see some complexities. In the indexing, as explained, to access any element in array, O raised to 1, but in the case of O raised to on, O raised to n, as we need to go sequentially to nodes. Space wasted 0 in the case of linked list O raised to n. How is space wasted 0? Because we are only storing the elements, but in the case of linked list we are also storing their pointers to the next node. And let's discuss insertion at begin. In the case of insertion begin, for array it is O raised to n. And why is that? Because suppose the array is of size 5 and you want to add an element, sixth element in it. Now you need to make a full new array of 6 elements that can hold 6 elements, and you will insert statically one each element, correct? That will take O raised to n time, but in the case of linked list you already know the head. So you will make a new node, make it as your new head and connect it to the next node. I already explained it earlier in the video, so you can watch that. Okay, thank you, and I hope you understand that. And please study linked list from Geeks for Geeks and other online sites, because it is one of the most important topics. Actually, algorithms and data structure is important, so I will recommend you to read linked list from other places if possible, to try questions, and we will see the coding part in the next video. Thank you very much.